During a study, scientists saw something that shocked them. They could not believe that they would actually see something like this. They also said, new discoveries from the Webb telescope and the Hubble telescope are further strengthening the claims of these observations. Few years ago, a team of theoretical physicists claimed to have discovered the remnants of previous universes hidden within the radiation left over from the Big Bang. The leftover radiation described here refers to the cosmic microwave background radiation. When our universe was very young, before any recognizable components like stars, planets, or galaxies formed, it was filled with a dense, hot soup of plasma. As the universe expanded, it cooled, and eventually, particles could combine to form atoms. Eventually, the interaction and fusion of these atoms resulted in all of the matter that we observe today. However, we can still observe the leftover radiation from that initial, dense period in our universe's history. This leftover glow, called the cosmic microwave background, CMB, is the oldest electromagnetic radiation, and it fills the entirety of our universe. This is what our current model says about the evolution of our universe. However, this group of physicists was arguing that our universe isn't alone. It's just one in a long line of universes that are born, grow, and die. Among these scientists is mathematical physicist Roger Penrose, who worked closely with Stephen Hawking. In one of his most famous theories, Stephen Hawking proposed that as a universe ages, it expands, and the constituent parts grow farther and farther apart from each other. Consequently, the interactions between galaxies that drive star formation and evolution become rarer. Eventually, the stars die out, and the remaining gas and dust is captured by black holes. And this isn't the end. Black holes might have a way to slowly lose mass and energy by radiating certain particles. So, after many eons, the remaining black holes in the universe would disappear, leaving only disparate particles. Seemingly a wasteland, this end state eventually mirrors the environment of our universe's birth, and so, the cycle starts anew. Penrose and his collaborators follow a cosmological theory called conformal cyclic cosmology, CCC, in which universes, much like human beings, come into existence, expand, and then perish. If Stephen Hawking's theory about black holes is correct, then the CCC model says, at the end of a universe, when those final black holes dissolve, they should leave behind a signature that would survive the death of that universe and persist into the next. And they named these leftover signatures as Hawking points. In searching for these Hawking points, cosmologists face a difficult obstacle as the CMB is faint and varies randomly. However, Penrose is claiming that a comparison between a model CMB with Hawking points and actual data from our CMB has proven that Hawking points actually exist. This discovery shocked everyone and was the first evidence of another universe. Unfortunately, as groundbreaking as this discovery seems, the scientific community has largely dismissed it. Because so many scientists said that anyone can find their favorite pattern in this CMB image. In fact, Penrose's former collaborator, Stephen Hawking, spotted his own initials in the CMB, while others have found a deer, a parrot, and numerous other recognizable shapes in the noise. Still, the possibility of alternate universes, whether long dead or existing in parallel to our own, is tantalizing. Many other theories also claim to find traces of other universes hiding in the patterns of the CMB as well. If we want to find the leftover part of the previous universe, then we have to find such things which are beyond our physics. Recently, scientists have said that there may be such objects in our universe, be it stars and galaxies or something that does not obey our physics. The laws of physics in our universe include a number of fundamental constants, such as the speed of light. However, many scientific models allow for the existence of a vast ensemble of universes, called the multiverse, which might include places where the laws of physics differ. Many researchers have previously suggested that sufficiently large variations in the laws of physics would result in lifeless universes, so that only small differences in the fundamental constants would be permitted. To examine this idea further, astrophysicists examined universes where law of physics might differ and speculated on the potential habitability of these alternate places. To test this theory, scientists are looking for something in the universe that is beyond the laws of our universe. Some astronomers said that, perhaps we can test this theory by studying the oldest stars and galaxies in the universe. And for this, scientists chose Methuselah, the oldest star in the universe. Scientists are still confused about the age of this star, because some observations tell us that this star is older than our universe. Methuselah, named in reference to a biblical patriarch who is said to have died aged 969, making him the longest lived of all the figures in the Bible, more than 100 years ago. The curious star is located some 190 light-years away from Earth, in the constellation Libra. After studying this star, scientists said that it was clear that the star was old. The metal poor subgent is composed primarily of hydrogen and helium and contains very little iron. Such a composition meant that the star must have existed when helium and hydrogen dominated the universe, and before iron became common. Scientists adopted every method to know the actual age of this star, but still they did not find any significant difference in the age of this star. Is this star really older than our universe? Surely that is just not possible. Either there is something about this star we don't understand yet, or the universe was not as young as scientists thought it to be. Similarly, the early galaxies recently discovered by the James Webb Telescope have confused astronomers. The newly discovered early galaxies do not follow our current galaxy evolution model. Some galaxies appear larger than previously expected, and one of these galaxies appears to be older than our universe. Astronomers also detected unexpected star formation rates in some early galaxies. Well, the early galaxies discovered by the James Webb Telescope are really different from our current theories, or the claims made on Webb Telescope discoveries may be false. Because, still these Webb discoveries have to go through a lot of observations, which will further confirm the claims made on them. But, what if these claims turn out to be true? Is there really something in these galaxies that is beyond the laws of our physics? Some scientists believe that the behavior of these early galaxies is different, because there are some particles that have not yet been discovered, or there is something that belongs to a different universe that we haven't found so far. So, as some astronomers were saying, if we find some such objects which are beyond the laws of our universe, then by studying those objects, we can find the leftover particles of another universe. And perhaps, this is the reason why Methuselah and the oldest galaxies discovered by the Webb telescopes are showing properties different from our model. If according to this theory, we do indeed find particles that are from other universes, and played an important role in the evolution of our early galaxies, then most of the unanswered questions will be solved.